Okay, in problem 2, we have Sarah Connor escaping from the Terminator at the end of the first Terminator movie. And so there's Sarah out here with her sort of long flowing hair or whatever. Well, it wasn't that flowing, it was like a ponytail or something, going, "Oh no, what will I do to save myself from the Terminator?" Because she's just crawled through this big industrial hydraulic press right there. And here's the Terminator coming after her. And it's lost its legs and like half of one side, but it's still, big and mean and ugly, and it's reaching for her. And this is, wow, that's the most horrible drawing ever. But there are the Terminator's glowing red eyes and its glowing smiley face red mouth. Okay, anyway, so what happens is Sarah crushes it, and she needs to crush it from a thickness of 20 centimeters down to a thickness of 3 centimeters. So, you could say this is like, I don't know, this is like H, I guess, is the thickness of the Terminator. H initial is 20 centimeters, and then H final is 3 centimeters. And so this hydraulic press has to crush it by 17 centimeters, which is 0.17 meters if we want to go that way. And we were given the maximum power output of the hydraulic press was 3.00 kilowatts, which is 3,000 watts. Okay, and the force needed to crush the Terminator, I'll put the F crush, is 80 kilonewtons, which is 80. Is that right? I think that's what I said. Let me make sure. 80 kilonewtons. Yes, 80, which means it's 80,000 newtons. Okay, so how long does it take Sarah take this thing to crush the Terminator? And there's like a metal, cage here that keeps it from getting to Sarah when she presses the little start button here. So, it crushes her. Okay, so power, as you recall, is the rate of work done per time. So it's work divided by time. Another way to express power, if you have an object moving and there's some force acting on it, so the object is moving through some distance, at some velocity v, and there's a force acting on it. So let me draw my object out here, and it's moving at some velocity v, okay, and there's a force acting on it. Say this is my force. Let's say it's a vector. Then and velocity would be a vector too. Then there we go. So then power would equal the force dotted with velocity. In this case, the velocity we're interested in is this plate coming straight down. So this is our velocity going straight down here, and here is our the force it's exerting going straight down. So they're in the same direction, so we don't have to worry about dealing with vectors. We can just use scalars and say power equals force times velocity. And we know the power it can put out, which is 3 times 10 to the third watts, okay, equals, and then this is 80 kilonewtons, so this is actually 8 times 10 to the fourth newtons times v. Okay, so this is power equals force times velocity, or force times speed, sorry. Okay, so speed v is going to equal this divided by this, which is going to equal 3 times 10 to the third over 8 times 10 to the fourth, and it's going to be watts over newtons. Okay, so what this comes out to is 0.0375, and a watt, you recall, is a joule per second, so it's joules per newton seconds. Joule per second is a watt, okay, and then we have the newtons there still. And a joule is a newton meter, so now we have newton meters per newton seconds, and this is going to then equal, so this is actually going to equal 0.0375, cancel out the newtons, and we just get meters per second. And what this really is 0.0375 newtons per second is actually 3.75 centimeters per second. Did I say newtons per second? I meant meters per second. Centimeters per second. And we know it has to be crushed by 17 centimeters, right? So this plate has to move 17 centimeters. So, so we'd use the old distance equals v times time, or we can use time equals distance divided by v. and then we get 17 centimeters divided by 0.0, or sorry, not 0. Anything, 3.75. And if we plug that into our power calculator, really need a power calculator for this, but whatever. Okay, 17 divided by 3.75 gives us 4.5 seconds. So the answer there is 4.5 seconds, which I think is it's been a while since I've seen the movie. And I think it's somewhat faster than it happened in the movie. I feel like it probably took like 10 seconds of the movie, and you saw the Terminator's eyes flicker and go dark like that, and then it's now I'm a dead Terminator. And then later on they came and saved its arm and used that, ironically, to develop the Terminator technology. But anyway, that's another story.